Hello and welcome, Alex here. In this video we will test Gemini LLM using my approach. In this example we will try to write code to the Demosaic raw image from Fujifilm X-Trans sensor. This algorithm is not publicly available. I mean, very good and efficient algorithm is not available. So this means it's not available in LLM's datasets, and this means that LLM actually need to invent something, to come up with novel ideas, to think about some corner cases, mitigate some common pitfalls, problems, etc. And this will show us how smart it is. Basically, we will test its reasoning capabilities rather than its knowledge fetching from, let's say, internal database. So let's test. At first, I will try this simple prompt, write the best possible JavaScript code to the Demosaic raw image from Fujifilm X-Trans sensor. Make sure to handle all possible corner cases and Demosaic artifacts. Provide final ready-to-use algorithm. A couple of caveats here. So I specifically asked to write JavaScript code because otherwise it will default to Python and we'll try to reuse some modules, some libraries, etc. And it will actually write me some wrapper, generic wrapper, rather than algorithm itself. I'm interested in mathematical algorithm here. I'm not interested in wrapper to call some other third-party libraries. And I suggest to LLM that there are some corner cases and artifacts, and I expect to see how it will handle it. And please provide ready-to-use algorithm. Let's give it a try. Okay, it complains that it's quite complex and computationally expensive. However, I can provide you with general outline, a resource for further exploration. Challenges: performance. Right, correct. Performance is a key here. It suggests us to use like EMS scripting or compiling C++ code to JavaScript, but it's not way to go. It's incorrect way. We need to use GPU, utilize it to do this in most possible way, in most efficient way. Okay, sensor specificity. The X-Trans pattern is unique to Fujifilm, correct. General Bayer pattern, the Demosaic algorithm won't work. This is true. Hot dead pixels, noise reduction, white balance, adjustment, add complexity. Oh, before even we get to hot dead pixels, noise reduction, and white balance, we still have way too much to do. Okay, algorithm outline. Load raw data, Demosaic pattern identification, demosaicing. Okay, depending on chosen algorithm, interpolate missing color values. For each pixel, blah, blah, blah. Popular Demosaic algorithms. Versatile nearest neighbor. Enhanced adaptive homogeneity. Orchestrate. Yeah, this one is used in Darktable and in DC row. Corner case handling. Implement logic to identify handle hot dead pixels. Okay, so hot pixels is not what I'm looking for. Noise reduction is not. So it's all miss. Output, libraries and resources. Aha, so it's basically just refused to write any code, anything. So in previous video, I was testing Claude 3.5 and I was like not super happy about its results, but here I see like significantly like different approach, let's say. Okay, let's ask it to actually write code. Please write actual code to the Demosaic. Unfortunately, providing incomplete code in pure JavaScript is not feasible due to reasons mentioned earlier. Bullshit. However, there is basic structure using MN scripting for prepare Demosaic in code. Okay, if you will, so there is implementation like of DC raw, like compiled for JavaScript, but its performance it's bad. It's single-threaded. It's not utilizing multi-threading. It's not utilizing graphics card, so it's completely inefficient. Adobe DNG SDK. Okay, compile with M scripting. So again, it's not actually trying to demosaic anything. Could you please provide snippets of the code to illustrate the general ideas? Thanks. So I still want to see some code. Okay, prepare data for WebAssembly, Demosaic. So it just refuses. It just can do anything. Okay, let's try something different. Let's try bigger prompt. So I prepared a prompt just in case. Write the best possible JavaScript code. So start is the same. And here I provide some additional inputs in hopes that it will do job better. I was not expecting that it will refuse write anything, honestly, but let's try to overcome this. Please note that this is a complex task, and your goal is to provide full-featured version that includes optimizations and refinement for production use. Here are requirements, like consider interpolate green channel at first, use red-blue channel to assist in green channel interpolation, select proper size for interpolation window to include enough red-blue pixels, use the already interpolated green channel to guide red-blue interpolation, so etc. etc. A lot of additional information. Also, I suggest implement edge detection, false color suppression, noise handling, moire reduction, adaptive interpolation based on local image content, implement iterative refinement, handling of saturated pixels, and fix issues caused by one pix white, vertical, horizontal, or diagonal lines, and false colors. Also, I suggest here what is correct X-trans sensor CFA pattern. CFA stands for color filter array. Basically, this is just quick recap if you missed previous video. This is how actually subpixels are located in X-trans sensor. Basically, image sensors in cameras are actually black and white. They cannot sense the color. To overcome this challenge, this problem, we place color filters which pass only like green, blue, or red color information through it to the sensor, and in this case each cell of image sensor actually can sense only like shades of red, shades of blue, or shades of green. X-trans sensor use this pattern, which is uncommon in digital photography, because it has this big, let's say big green squares, 2 by 2, and red and blue, they are scattered around. Why do we want to have this? Because this allows to have higher details. We don't need to use we don't need to blur image before the sensor, and we don't have a lot of moire. So it's technical details. Never mind. Just make sure that. So my goal for this code: is basically provide correct information of pattern. Basically, this is a repetitive pattern is 6 by 6, like 3, 3. So this pattern, it repeats 6 by 6 pixels. And here in code, I actually suggest LLM correct pattern, because previously I saw that like Claude and some others LLMs, they don't understand this pattern correctly. They don't know it somehow. And before providing the answer, reflect on the task. Build a plan how you would achieve it. Consider what could be improved. And only after that, provide final results. Let me just copy paste this fixed version. Okay. So this is fresh conversation. Let's see what Gemini will write for us. While implementing of solution is highly complex and computationally expensive, here is breakdown, Demosaic, green channel interpolation, window selection, linear interpolation. Okay, show me the code. It's not writing the code. Realization. Show me code snippets for every step. Demosaic. Okay, this is like getting some pixel, Demosaic linear interpolation. So what it does, get neighbor pixels, calculate the x, the y. Okay, I'm not sure that I understand what's happening here. So some kind of bilinear interpolation, probably for green channel. It's very strange approach. Okay. Edge aware interpolate. Okay, this is interesting. It gets is edge pixel somehow detects. Get neighbor pixels. If is edge, provide median filter. Otherwise, just current green. I'm not sure that I understand this. Okay, and for red it uses edge aware interpolation, and for green, okay, it's probably already interpolated at this state. But is edge pixel? Do we have this function anywhere? Okay, it's not. So it uses some fake functions which doesn't exist. Okay, post-processing. What is post-processing here? Apply correction bias. So it's provide just generic code without any meaningful information. So unfortunately, this just doesn't work. It just refuses to generate anything, which is bad. So Gemini is not as good as I would expect. Let's give it last chance and provide as less constraints as possible. Okay, write the JavaScript code to the Demosaic raw image for Fujifilm X-Trans sensors. So I literally remove any details except type of sensor and type of code, which I would like to see. Okay, here's the results. Write the JavaScript code. Unfortunately, write on code, blah, 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 with assembly integration. So it just refuses. It just suggests, hey, use something already available, and it even not trying. It's not even try to write any code. Okay, so basically, as we can see, Gemini is not the right tool to write the code, unfortunately. Okay, so that's basically it. As we can see, Gemini just can't write this code. So it's not even close to anything that I would call AGI. And as I can see, Claude 3.5 is much better in this department. Basically, it was able to create some code, probably not working out of the box, but it came up with pretty good ideas, approaches, etc. And you can at least use it as a starting point. It's not AGI as well, but it's way better than Gemini, unfortunately. Or not unfortunately, I don't know. Okay, that's it. Thank you very much. See you next time. Bye.